Hello.
Hello.
Oh,
Can you hear me?
finally. I'm not sure why.
Yeah.
Yeah, I can hear you just fine.
Cool,
I'm
cool,
not
cool.
sure why. I cannot log in all this time. Sorry for being late.
Yeah, sure, no worries.
So you are here for a system design interview, right?
Yes, exactly.
Cool. I have 3 questions before we start.
Mm-hmm. Right. So, for the first one, I guess my name is Leon. I'm just currently a software engineer, mostly in backend at AWS. Um, yeah, I have been there for like almost 2 years. Most of my background is in backend. Also, I did have some full stack and front end uh, experience during my college time, but for now, it's just mostly backend development. Um, for the level, targeting level, I guess it's E4 slash E5 at Facebook, and my personal goal is definitely E5. Currently,
Okay.
I'm L5, which is basically is D2 at Amazon, with the kind of a promotion case targeting Q4 for senior engineers. So pretty much on the way for the E5 at Facebook.
Okay. Sounds like a plan.
Yeah.
And the other thing is, have you done any system design interview before? Like
Not
mock?
really. I just
Okay.
my first mock interview was actually today during the day with my friend, but not a lot of experience with the system design
Oh,
interview overall.
okay. Well, as long as you have some prior experience, so you know like what's the framework you have to talk about, so that's
Yeah,
fine, I guess.
yeah, yeah, exactly.
Cool. So before we start, I want to set up expectation real quick, right? So the interview is going to be 45 minutes at Meta,
Mhm.
but the first 5 minutes is mostly about greeting or restroom break. But
Mhm.
ultimately, the goal is so that you are not nervous. I hope
Yeah,
you are
sure.
not nervous right now, so you don't have to waste
Yeah.
5 minutes.
No,
I
no.
can
Oh,
crack some
okay.
joke if you want.
No,
I'm
it's
just
fine.
kidding.
It's
I
fine.
don't know any jokes.
Yeah.
All right, all right. So the actual interview itself then is really just 35 minutes, right? So now it's all 7. Let's try to finish by 42 and use the remaining
Mhm.
time for feedback. Sounds good to you?
Okay, sure. Sounds good.
Okay. So since you are between E4 and E5, I'm going to use the question that is typically used for the people in that level.
Okay.
So which is online judge.
Right.
I assume you've done lead code before.
Yeah,
Code.
sure.
So I basically want you to build that, right? Which is,
Mhm.
given a problems, then you can, submit code, test code, get result of submission, and so on, like all of the stuff.
Mhm.
So that's
Okay.
basically like I want to design an online judge.
All right. Sure. So, we go.
Yeah, go ahead.
Cool. So before we continue with the problem itself, I just want to set up some sort of agenda here, and in terms of how I see the interview going. So I'll just start with a kind of a requirements gathering. Then we'll just continue with some high-level designing and deep diving into one of the areas like scalability, availability, and stuff. So actually, before we begin, I'd like to clarify the actual priorities for this interview. Like, what is the most what are the parts that you're most interested in terms of technical design? Is it just like scalability, calculations, all this kind of stuff?
I think in this case, what will be most interesting will be like how are you going to execute the code safely,
Hmm. Hmm.
right? Because I could theoretically, give you like a malicious code as a submission,
Okay.
and that might have like any connections with database, and I can theoretically drop the database if I have like
Okay.
this code.
Okay. So.
The other one, I guess, is the high level design. That's probably like what's interesting. The particular deep dive, like there is nothing that's pretty interesting other than that.
Okay, so basically, as a CEO, we're mostly constrained on the security of the execution of the code and overall high-level design, right?
Yeah. Mm-hmm.
Okay, cool. So,
Security and high-level design.
okay, cool. So then let's start with quickly going through the functional domain. So we're saying like the users should be able to uh, submit the code, and as a result, they will get just a result of the submission, right? So as I understand, users will just submit code, and as a result, they will get just some sort of result for the submission. Okay? Does it make sense for you?
Yeah, sure.
Okay.
Like what about like actually like listing the problems?
Mm-hmm. Sorry, what was it? Oh, you mean like a retrieval of the problem?
Yeah.
Okay.
So you might want to check out the problem as well, right?
Yeah, exactly. Sorry, what was it?
No, yeah, just this one. Just you want to check out the problems, not just submit problems. Not just submit the solution.
Yeah, for sure. So we'll just get the problem first, of course, and then we'll submit the solution for it, right? So, okay. And I believe this is pretty much it for the overall functional requirements. Like we're getting the problems and trying to solve it. We'll solve it like the user will write it locally, I guess, in the web browser, right? So we will just have a client based in somewhere in a like web platform, like browser application, right?
Mm-hmm.
Okay, cool. So then in this case, they will just get the problem, read it, and then try to create some local code. And I assume they will execute this remotely. Like they will submit the code, and code will be executed actually on the server side, right?
Mm-hmm.
Can I? Okay,
Cool.
sure. So,
can you just write it down?
Execute on server side.
I'm gonna tell you why it's very important for you to just write down everything.
Yeah, sure. I'm just clarifying things just to make sure.
This is for you. Tips number 5 for you.
Okay, cool. Okay, so and then okay, cool. So and then so basically for the other non-functional things, do we care about the scalability or availability right now, or just we'll talk about later?
About scalability, you can talk about it later.
Okay. And if we will talk
you should assume you will have to write that a scalable system.
Okay.
But like you don't have to go deep into it at the moment. If that's the question.
Yeah. So I'm mostly targeting. Trying to.
By the way, let me also give you tips number 7 for you.
Mm-hmm.
Just in case, so that like like how to do timekeeping.
Mm-hmm. So yeah. Yeah, exactly. So I'm just trying to understand the scope of the problem and how scalable we're targeting, like whether it's going to be a small system or just a system that should support a large number of users. For now, I will just notice it should be scalable, and we'll go from this. And like last but not the least, should we? So my assumption is that when the user so storage of the problem should be consistent. So whenever the user gets the problem and tries to submit the code, we actually probably will not store this code. We just will execute it. So I'm curious about whether we want to concentrate most on availability first or on consistency. And my suggestion would be here to be like availability, because we don't really have anything to not much data to consist here. So Is it the right assumption in this case? Like availability over consistency overall?
Sure, I guess.
Okay, cool. So, all right. So in this case, I'm pretty much okay with the non-functional requirements here. So, do you have anything to add, or am I missing something?
Again, about the security, the non-functional, right? Sure, probably
yeah.
the security on server side, but how do you do it safely?
Yeah, so it will be securely securely executed, right? Okay, so all right, that makes sense. So, do you want me to do any kind of estimations like traffic and what we're targeting in terms of the scale right now, or can we do it later on?
Yes, please.
Okay, sure. So
you can do it later, but like eventually you have to talk about it.
yeah, sure. So I assume that if we targeting a large scale system, let's say we'll have like I don't know what 10 million daily active users. Does it make sense to you? Overall.
10 million, sure.
So, and let's say for these 10 millions, we will have a distribution like, okay, 10 million users, and we will have some sort of a probably peak time between, I don't know, maybe 5 and 8 p.m. Actually, if it's in like global system, we probably may assume that the traffic will be distributed equally. But let's say at the peak time we will have I don't know, like 40% of the traffic per 2 hours, right? Like maybe some of the North America regions between 5 and 10 p.m. There are most of the users are who is actually using it. Does it make sense for you?
Sure.
Okay, so in this case, if we have 10 million daily users, 40% of 2 hours, then we say like 20% of the peak traffic will be within 1 hour. And in this case, if we multiply 20% to 10 millions, it will be just like 2 million per 1 hour, which is equal hour, which kind of equal to 2 million by 360. So we're targeting somewhere around like 600, let's say overall traffic, like GPS or TPS, like GPS and TPS combined. And we can talk a little bit more about the write versus read ratio. So, and I believe that in our case, we will have more some sort of write transactions to the service to submit rather than getting a problem. Or actually, it could be, yeah, it will be a little bit more like, let's say, 60 or 70% submissions and 30% 70 submissions, and 30% will be getting the problem, right? So, and if we're doing this kind of thing, then we'll say like we are targeting around 420 TPS for like submitting the problem, and around 180 for TPS to query the problem statements. Okay, so far so good.
So far so good. Yeah.
Cool. So yeah, in this case, what we can see is that, okay, so what we can see overall, this system doesn't have, we assume that it will not have very large traffic at the beginning because 600 QPS TPS is kind of a manageable overall in the system, but we will still make it in a way, we will create the system in a way that it could be scaled for further traffic, okay? So
Okay.
for storage bandwidth and memory, I would like to estimate this once we're done with some sort of data or storage models. But for the approximate things, for bandwidth especially, because we're going to submit some text to the service, as I assume, because we'll just treat it as some sort of a text. Let's assume that it will be on average, like for submission, it will be on average, let's say, I don't know, like 30 kilobytes, just from top of my head. And for a problem statement, it will be somewhere around, I don't know, like 10 kilobytes of text. Does it make sense?
Okay.
And actually, and here, and problem statements here as well. Let's assume that we will have, I don't know, like maybe we'll have in our database, let's say 100K problems, which translates to multiplied by 10, which translates to 1 million kilobytes, which is kind of a 1 gig of data to store in terms of the problems itself. Okay. So far so good. So based on this storage, it's kind of a small, so it's cool. Not much of the DDB or storage constraints right now. Does this assumptions for 30 kilobytes per submission and problem make sense to you?
That's per day, right? Or per second?
It's for now. I'm just saying like this is per problem, like submission, 30 kilobytes per submission or per request, and this one as well. So in this case, what we're saying is that if we have 420 TPS for submissions, it will be approximately 13 megabytes per second of bandwidth. And here, what we have is that we have 10 kilobytes and 180 QPS. So it's around like 2 megabytes per second. And in total, we're expecting like, let's say 15 megabytes per second of bandwidth. So it's kind of a manageable overall based on this assumption. So it's not, the system initially doesn't require a lot of computation, networking capacities, let's say like this, and computation in terms of traffic itself. But again, like as I said, we will try to make it scalable in case if we will have more in the future. As for memory, we can just talk a little bit later once we define our caches and data models. So I'll just keep it for now if it's okay for you.
Okay, sounds good. Just a real-time feedback here. So you are going to the right directions or explanation are correct, but you should have done this 6 minutes earlier, sorry.
Okay, got it. Okay. Sounds good. Then, yeah.
So that's why, going back to number 7, you don't have to keep asking me, like, whether this is correct or not. Just keep going. If I found it's wrong, like, I'm going to interrupt you.
Okay. Then let's continue with the high-level design. So I guess I will use the Xcode draw, right? So let's start with our client here. So let's say we have a client as a web browser. And then we will have customer sending code to our service, and our service will actually, let's consider the first flow of getting a problem statement. So let's say we will have some database with the problems. So initially the flow will be like customer sends request to the service, and then it goes to the database and then it returns with the problem, right? Then second flow would be like actually submitting the code. The flow will be pretty much simple as well. Client will just call the service, and service will execute the code somehow, and then return the result of the execution. Whether it's actually one more thing I would like to assume is that the problem will be submitted, and service will just respond with the like either 400 if something malicious is going on, or yeah, I guess 400 status code for HTTP call now. And then if everything is okay, we just respond with the 200 with the some sort of a decision on the problem itself, whether it's successful or not. Now let's continue with more digging a little bit more of how we will make this system scalable. So first of all, for our client service communication, we will just add an extra component like, let's say, API gateway. Oh, actually, one more thing I'd like to clarify. Is it okay if I will just refer to some cloud services as an example of some system components?
Like what?
For example, using Lambda for serverless execution of the code.
Sure, I guess.
Okay, sure. So let's just start with the extra layer for our scalability purposes. It will be just API gateway, which will be responsible for things like throttling, authorization, and load balancing for sure. So like it will be just a first point of load balancing the traffic overall. And once we pass the throttling, authentication stuff, we will go to the service itself, and we will either return the problem to the user or execute the code. So just a few things on actual security, if you'd like to discuss right now. One of the things I would like to consider is actually creating these two services, actually all of those services, in their own private containers, just to make it secure in case if we miss something in our submission payload validation. So we will just create some sort of private containers for each of the layers we have. And it will be just like VPC stuff, like virtual private container, and it will be separate for each of these layers. So the purpose of this is actually just to make sure that if something goes wrong in one of these layers, like a public, like we will constrain what could go out of this container and what could go in. So for example, for this API gateway layer, we will say that inbound connections could be from any public resource, like maybe not from every public resource, if we will have our own some sort of a client, so we will be able to check where we will be able to generate some sort of authentication tokens on client side in our web application. And yeah, so we will define some sort of authorization there in this case. So we will say like, hey, for these kind of authorization tokens or signatures, we will allow the traffic from those source points. And then we will allow the outbound traffic only to this service, which will be responsible for computations and for now, like retrieval of the problems. We could further then divide this service into two, like service for problem statement service, let's say like this, service. And then we will have a separate one, like problem, like code execution service. Code execution service. It will be also in two separate private containers. So And again, like as I said, we will, for this particular code execution service private container, we will make it possible for inbound calls to be only from API gateway, and we will restrict any outbound connections if necessary. And actually, one more thing that I just considered is that when we will execute the code, we will need to some sort of do some validation, like testing of the code, right? So in this case, we will actually need to communicate to some sort of a database, which will contain a test set and with the input and expected output, right? So for now, I'll just create it as a separate database. Actually, yeah, we can just do it in one database for now, and we'll see how it goes. So this database will be responsible for storing problem sets as well as a problem. In part of this problem set, for each problem, we'll have some sort of a test set with the input and expected output. Okay, so all right. What else we can go through? Do you want to go deeper into the security stuff?
Sure. Like how are you going to execute that code?
Yes, exactly. So in order to execute the code, we actually can create, okay, API gateway will be just a lightweight thing. And okay, so when we start executing the code itself, we will need to do some sort of a code verification step where we will just make sure that we will do some sort of verification for the malicious code. For example, the code that tries to access some public resource or external resource, or execute some SQL queries. We will need to actually prevent any outbound traffic to anywhere, because we assume that the code submitted for this specific problem will be just written as a function. And yeah, we will define for our clients that in order to submit the code, you will need to modify, you'll need to implement some sort of a function as defined in the problem statement itself. And in this way, we'll be scoping the code which will be executed. And once we will try to call this code on the server side, we will basically constrain any external communication at first. And yeah, that's one of the security measures. We will also have some sort of let's say, coordinator service or back pressure inside of each of server that executes the actual code by saying that, let's say, we will allow this particular problem submission to be to consume at most, like, let's say, 5% of CPU per host on this specific host that executes the problem. And we will say that this problem cannot run more than like for I don't know, 10 seconds as an example. So this will be just two verification. Well, one of a few verification steps. Let me just write it down properly. So we will bound code to a specific function to execute. We will constrain all networking for the problem. We will constrain max CPU allocated for the submission. Let's say submission, let's say 5%, and we'll constrain running time, like a clock time, for that submission. Let's say 10 seconds or so. This kind of a
how are you going through this?
Sorry, what was it?
How are you going through this?
Going through what specifically?
how are you going to do this?
Oh, sure.
What is the means to get this actually done?
Yeah, okay. So let's say for bound code to specific function, it will be just on the problem statement level. We will say that, hey, you need to implement this function signature. Then when we get a submission with the code, we will process the submission text and we will look for that particular function to be executed. We can just compile it or do some sort of a finding of this particular function, right? So for the network constraints, it could be done on different levels. It could be done on application level or networking level. We could just do it on VPC specific customization level or firewall if you wish. So what we will do is actually we will say, hey, for firewall settings, we will say that there is no permitted networking connections from that specific function integration. Actually, if we do this on VPC level, well, we may still be leaking this DDP connection. If somehow the users will figure out how to connect to the database, they will use this kind of a hole. So in this case, we will need to do it on the application level. So we will say that whatever program we use to run the code or like on operation system level, we will say that for that specific process ID that is going to run the submission, we will restrict all the networking communication. So, and then for the max CPU allocation for the submission, we may create some sort of a special engine inside of the service, or we can containerize the submission itself with the configuration of allocating maximum 5% of CPU utilization. And similar will go with the time constraint when we have some sort of a engine service, like not engine service, like internal engine for running the submission. We will say that that particular submission may not run more than this amount of seconds. And this kind of configuration could be also dynamically distributed either from database or some sort of other dynamic configuration service, which could be either on per level or per some problem level defined or like a per host level defined. Okay. Any further questions for this?
How are you going to, so there is going to be an API.
Mm-hmm.
You're going to be calling around here and here, right?
Yep.
So are they going to be synchronous or is it going to be asynchronous? Executing the code will take a while, right?
Yeah, that's true. So that's a good question. So there are two options to do this, like synchronously and asynchronously. In case we do go into do it synchronously, customers or clients will be actually waiting for code submission to run and complete with some response. So it's kind of a viable option. The only drawback here is that we will sustain an open connection to these services to actually run the code. Another option is to do this asynchronously. So, and by synchronously, what I mean is that once the client sends, so one more drawback of synchronous invocation is that it may be, this API gateway layer and code execution service layer may be highly coupled in terms of scalability. And specifically, they will be bound to the, again, like maximum number of connections open. And as we know, like for each Linux machine, it could be around 60K open connections. But if we go to the synchronous approach, we will do some sort of a queuing here so that we can offload the processing of the tasks to the workers, and those workers will asynchronously poll for this for those specific problem submissions. So, for example, we will have some sort of a message queue here, We will then send a task there, and workers on the code execution service will be polling for it, for those submissions, to process them. So once this processing is done, we could either notify the customer about the completion of this execution. So let me just think about how we can do this. Ta, ta, ta. Oh, okay. So if we doing some sort of a if we have some sort of a web application on our client side, what we can do is actually uh, let me just think about it. So, okay, I see. There are several options to this. So, for a synchronous approach, so we can just send from our client application request to API gateway, which will send the message to the queue, like submission to the queue, and then we will respond right away to the client saying that, hey, we start your code execution asynchronously, and and here's, for example, an ID for this submission or execution, right? So then what will happen is that workers will poll for the message and will process this, and then we can have some sort of a separate queue, or even not a message queue, or just event queue, which will be notified once this code execution completes. And this event queue, we can configure it in the way that it will notify the client about the completion, or client could do some polls for this event queue, or in this case, it will be more like a message queue, to get this, to check whether this execution has been processed or not. So pros of doing the push pattern is that we will there will be less latency between actual completion of code execution and notifying the client code of our web application. The cons of this could be that we will need to store some extra data to actually know how to communicate to that browser. For the polling architecture, we could scale the system more dependently in case if we have a lot of executions. Actually, it should be prevented. But in any case, so for the polling, So for the polling, we may consume extra resources on the client side, because in case if we're doing a short polls, we can do a long polls to register some sort of a backdoor once the event is complete or event is needed for that execution. Or we can actually create an event stream directly from the event queue service in the way that once the event is created for that execution, it will be sent right away back to the client. So overall, I would go with the push model here, just to make sure, in case if we wanted to process those things as soon as possible.
Okay.
Yeah, another option is to do the WebSocket communication, so that we can just create a stateful connection to the server that actually expects for code execution. But in our case, it will be, I believe it will be just a short-term communication with the service, not like we're just waiting for something. So actually, I'm just thinking it once more. I think long polling would be the best here because we doing a short-term communication. We will not. Basically, we're aiming like 10 seconds of invocation, so we can just do a long poll of 10 seconds. And if we do not get any responses from message queue, like event queue for this one for code submission, then we'll just say, hey, it's time out. So sort of a time limit exceeded for that specific problem. There are drawbacks like networking delays, which could produce false negatives. But yeah, it's one of the drawbacks actually for the polling. Okay, does it make sense so far?
Yeah, makes sense. Do you wanna just quickly talk about API and schema? You
yes,
are
exactly.
already a little bit over time.
Yeah. So for the API things, let's start with the POS, which is
just do it very quickly. You don't have to explain it, by the way. Like you are already 4 minutes over time.
Okay, sure. So for the submission, we will just do some sort of a RESTful HTTP communication because it will be better than RCP in our case, as we just aiming to create like overall generic communication between client and service. So we will just create a post with the, let's say, submission slash the ID for the submission or something like this. I cannot just come up with from top of my head, but the thing is that we will, as part of this post request, we'll create a payload for the text. As it's going to be like pretty small, as we discussed before, it's around 30 kilobytes or so. So it should be processed pretty well as a post request, as a post HTTP request. We will also submit like some sort of a metadata for authentication, as well as some problem IDs probably, or something that we could identify and map between the submission payload and actual problem statement or expected test results. So, and as for the getting the problems itself, it will just get a request for like /problems/ID of the problem, which will return as a response the problem statement and a few examples for that problem statement. Actually, problem statement could include those examples, test cases.
You don't actually have to explain it, by the way. Like I just want you to write down like API and schema. Like you are already 6 minutes over time, or do you want to just be done with this and then like I give you the evaluation? I mean, obviously you know what you're talking about, but like it's kind of useless if you talk about it beyond 35 minutes. That's what I'm trying to say.
Okay, so your suggestion is actually just writing it down right away?
My suggestion is that like next time around, yes, you should just write it down right away. You don't have to talk about it. Just write it down.
Okay. Yeah. I just was a little bit confused. Okay. So, in case of these APIs, what was your expectation overall? Because when I started to do some sort of schemas for APIs, you said that I don't need to do this, so I got confused about it, and that's why I stopped writing. So, sorry, what was it?
When did you talk about the schema about the API?
Yeah, just a few minutes ago. Then, in the end of the interview itself, I started to talk about this.
No, I was just saying like you don't have to explain your solution. Just write it down.
Oh, just silently write it down.
On the API, you don't have to explain why post makes sense, why REST makes sense. Just write it down.
Okay, so like just writing it down.
Yeah, exactly.
Do I need to think out loud, or I can just write it down and that's it?
Thinking out loud is fine, but most importantly, just write it down.
Okay.
Have you read my tips number 5? You need to persist all discussion. Like, it's more important than you talking it out.
Okay.
Like, whatever the interviewer is going to get after the session, right? It's just going to be your writing. They will completely forget whatever you talk about. Like, completely. Every single thing that you talk about, they will forget. So if you have any option between like talking or writing, choose writing.
Okay. Yeah, it makes sense then. Yeah. Okay. Sure. That's a good note.
Yeah.
Okay.
So the things like here's your evaluation, right? You do everything right, but your time management is kind of awful, right? And I have given you several tips in the between how to do time management better. Don't ask questions to the interviewer. Just keep driving the conversation. If it's wrong, the interviewer will let you know if it's wrong, right? Why this is important? Because you only have 35 minutes.
Yeah, that's true.
And then again, like, because of this, right? Because you're going to deep into some areas or whatever, like, you end up you didn't have the chance to talk about the API and the schema. Like, what is the relation between like the problems and the test case? What is the relation about the problems and the submission? What is the relation between the submission and the test case? Right? These three things are very important for this question. Right? Sure, the code execution is very important, which is I give you the credit on like what went well in point 4. I'm the interviewing.io, by the way. Like, I give the feedback here in the interviewing.io editor. I'm not sure whether you see it or not.
Yeah, I see it.
But so I give you credit for like solving the primary problem that needs to be solved here, right? But you didn't check all the boxes, like the fact that like you didn't cover the it's a good complex solution, and then good component securities. But you have to kind of like go to the API and the schema, especially for this question, because the data schema is going to be very important, right? The API also going to be, that API might not be that interesting, right? You know, it's just going to be like a 2 API, a post, and like get on the, maybe 3. Posting the submission, getting that submission ID, like the primary if you're using polling, as you mentioned before, and like getting the problems, right? But the data schema between like the relations between like all these different entities, right? How is the submission correlated to like test case? Especially why is it important is because you need to know what you have to pass to your containerized executor.
Yeah, exactly.
Like, which I want to bring up one point, right? In your drawing, right? If you want to do like a containerized service to execute some code, you gotta split it up, right? So this is like, you know, containerized executor. So why is this important? It's because, like, as you can see, this containerized executor doesn't connect to any database. Your code execution service connect to database. Like this, for example, right? You can get like the, you know, you can request a submission ID and problem ID from the code execution service, and then you can get like the actual code input, expected output, right? So what's going to happen is that, like, you will pass the code input, expected output into containerized executor. As you can see, this executor will know what it needs to do without actually connecting to the database. And this is how exactly you secure this, right? So you gotta make it super clear, like the data flow, right? Sure, it might be super clear on your in your head, right? It's kind of like apparent from like whatever you're writing here, but like the interviewer is not mind reader. Like I've seen this problems hundreds of times. I've been this interview like thousands of times. But like, you gotta tell me like exactly like what's happening here, right? Especially the data flow here, right? How are you going to make it exactly secure? Well, you split it into separate containers, and you actually only pass the necessary information. You don't allow the container execution to talk with the event queue, to talk with the message queue, to talk with the database. Like, you just don't allow it. You have like some kind of manager to do it for them. So that's how you secure it, right? But overall, like, you solve the puzzle well, right? And that's why I still give you a higher E4. But ultimately, the biggest issue to getting you to E5 is just the completeness of this, right? The fact that you don't talk about the API, you don't talk about the schema. So I would say not bad for, you know, your first, you know, real attempt on system design. right?
Yeah.
But you really need to up your time management, right?
Yes.
You don't have to keep asking questions to the interviewer. Like the interviewer, like I've been doing this like hundreds of times. Like we want you to kind of like drive the conversation, drive all your assumptions, right? If it's wrong, like we'll let you know.
Okay. Okay. So basically, as I understand, the approach will be I'll just write down my assumptions and how I actually consider my consideration about the system itself, and then if something goes wrong,
Exactly.
I'll be okay. Got it. Okay. Yeah. So because
Exactly.
when
You
I
can
was
see like whatever you have written here is quite clear, right? Like the interviewer will be able to see like, okay, this was what you considered during the interview. And then like at the same time, like for example, if the interviewer has to kind of like take a look a little bit and think, is this gonna be an issue during the system later? Because like there is really not just one particular solution. Like there is no just one particular problem statement. Like in your non-functional requirement, in your numbers, you could have come up with different numbers. For example, one candidate can talk about like 10 million DAU. Other candidate can talk about 1 billion DAU. Other candidate can talk about 100K DAU. That will have like different implication, and we will love to see that, right? I don't want to use my number. I want to use your number, right? So don't ask me questions.
Okay, got it. Okay, yeah, makes sense. Okay, cool. Do you have anything else to talk about here?
I think the other things is so this is the tips, right? So I think you do well on like calling out API gateway, so that's good. I put it into deep dive. So here's the thing, right? If you do it, if you were able to kind of like manage your time better here, like there is even a possibility for you to get an E6 at least on the system design, right? Even though like it might be impossible because you're gonna go better for E4 and E5, but with this details, with all of these different deep dives that you did, right? It is actually possible to give you E6. I mean, not for this question because this question is for E4 or E5 calibration.
Yeah, sure.
For different questions, if you talk about like this kind of deep dive, it's good enough. But you want to check all the boxes first.
Yeah.
Before you go deep dive, check all the boxes first. Data API, data schema. Do not forget about them. Timekeeping. This functional, non-functional requirement. To be exact, like this is the timing that you want to hit, right?
Yes.
What I mean by 1, 2, 3 is that like, so I'm going to give you the framework. So very similar to yours, but this is kind of like the framework that I have in mind, that I typically teach my candidates. So very similar to yours, right? But like you just want to make sure that their functional, non-functional, and numbers is 10 minutes. You did it in 16 minutes, 17 actually. You want to do it 7 minutes faster. How to do it? Don't ask questions. Just keep making assumptions.
Yeah, makes sense. Okay.
Also, in terms of calculating numbers, you can do it like really quickly by doing this. And then one last thing, number 8. Your biggest enemy is not your technical skill. Your technical skill seems to be fine, but it's time. Remember that you only have 35 minutes. And because of that, I strongly suggest you to watch YouTube videos because YouTube videos are time bounded. So you will know like, okay, at minute 10, what should I talk about? At minute 15, what should I talk about? At minute 20, what should I talk about, right? So you know like exactly how to manage your time better. So that's why I would recommend you like YouTube videos. I give you a list of this, right, for practice.
Okay, cool. Thanks
but
a lot.
Otherwise, I think you are good to go.
Cool. Yeah, I'll definitely will try to make it faster. It's actually the same kind of feedback I got from my friends because I saw that I spent too much time on requirements itself, but it's more about the reason why I spend so much time is like based on my kind of expectations from the interview and what I read before about this interview is that it should be communication. So that's why I try to make it more like a dialogue rather than monologue. So probably it's a mistake. Okay, I got it then.
The dialogue part should be like on the solving part, not about not when you're getting the requirement. The other thing is that like you could have talked about high level design, API, and data schema at the same time. So you don't miss that. So when you start drawing this API gateway, start talking about, hey, I'm going to use posts and then this is going to be like a submit, and then the request is going to be something like this, response is going to be something like that, right? And then like when you hit this event queue, for example, I'm going to get like, a submission and submission ID, for example, right?
Yep.
Well, my request is going to be something like this, response is going to be something like that, right? You can do it like very quickly this way, exactly during your drawing, right? You don't have to split it into separate sessions. This is going to make it much significantly more clear compared to like if you split it into different sessions.
Okay, yeah, makes sense. Okay, cool.
And you will save like 10 minutes time because you are doing this.
Yeah, that's true. Okay, cool. Yeah, it's definitely lots of feedback, useful feedback.
Cool. Any last question before we end the session?
No, not really. So as understand, once we end this meeting, I will be able to access these notes, right? Just want to make sure.
Yes, you will be able to see everything.
Okay, cool. All right, then I'm pretty much got a very good experience here. So thanks a lot for your time. And for the feedback for sure.
Cool.
Yeah.
All right, man. Good luck with your practice and your interview as well. Yeah.
Thank you very much. Have a nice day. Bye.